Today we will show the other diagrams like class diagram, sequential diagram, etc. So first of all is class diagram. A class diagram actually describes the static structure of a system. The static structure of a system. That means the blueprint of a system is shown by this class diagram. It shows a system is structured, how a system is structured, and rather than how it behaves. It do not show how it behaves. The behavior of the class is not shown here, only the structure. That means how many data members, how many functions or methods are associated or operations are associated with this class, that is shown through this class diagram. The static structure of the system comprises a number of class diagrams and their dependencies are also shown here. Okay, the dependency between different classes are also shown here. The main constitutes of a class diagram are classes and their relationships like generalization, like aggregation, association, and various kinds of dependencies are shown through this class diagram. And the classes actually represent some entities with which have some common features, that is attributes, operations. These are the entities of a class, and each and every class represent a solid outline rectangles with some compartments, mostly three or four compartments, and the each and every class is designed by the rectangle box. And classes have a mandatory name compartment where the name is written centered in boldface. The name at the topmost compartment here, the topmost compartment is the name of the class, and this is in a rectangle box, and this is one compartment, second compartment, third compartment, and the first topmost is the name, and it should be written in the middle, and obviously bold face. If you make it bold, then it is visible, easily visible. The class name is usually written using mixed case convention letter, that is the first one is W is in capital, then I is in small, N is small, and if there are some another word like window, watch, for example watch, then watch W should be capital, and other letters are should be in small letter, but there should be no space between these two names because this is a single name and without any space. Okay, now the class object name are written using mixed case convention, but start with this we will find out when we will learn the object name, and in case of object name, the object name should be start with a small case letter, but the class name should be capital case letter. The class name are usually chosen to be singular nouns. This should be normally chosen by a singular noun. The classes have optional attributes and operational compartments. This is optional attributes and this is operational compartment. These are the attributes, these are the class name, and these are the operations. A class may appear several diagrams. Its attributes and operations are suppressed on all but one diagram. মানে একটা ক্লাসের there may be several class diagram, but all the operations and all the attributes are to be found to be stored into a single diagram. But one may but why there are so many representation of class, this may question arise to you. The answer is that the different notations are used depending on the amount of information about a class is available. Different available information. Sometimes you have only information that there is a class name window, so you will draw only this part window. These two attributes and operations are to be omitted in that case. Sometimes you have only the data members of the class, you have the information, but you don't have any information about the operation of the class. What are the operational members are available. So in that time you will draw only these first two compartments, do not draw the last one. Okay, so that's why there are so many representation of the classes. At the start of design process, only the names of the classes is defined. This is the most abstract representation of the class. Later in design process, the methods of the classes and the attributes are defined, and other more concrete notations are also used. Now, here is the example of different types of class. This is library member, library man. The three types of representation. Here we know only the name of the class, and look that there is no blank space between library and member. Between these two words. So keep in mind when you are writing the name of the class, then it should be start the capital letter each and every word, and there should be a single name of the class. And in this case we have only the operation members of the class, but all the attributes are unknown here. So all you write all the operation members, and in the middle tier are omitted here. In this case the whole things are available. Now what are the attributes? An attribute is a named property of a class, and it represents the kind of data that an object might contain. Into an object, what are the data may contain? Those data are attributes. Attributes are listed with their names and may optionally contain specification of their type also. Type means what are the types of those attributes. Suppose if we use that x is a variable, like it is integer type or float type or any other string type, etc, etc, this should be the type also available into this attribute. And initial value and constraints are also may be available into a class attributes. Class names are written into a left justified system, and it should be written in plain letters, and the names should be in the lowercase letter. Okay, attribute names may be followed by square brackets also here, like sensor status. This means that it containing multiplicity expressions. That means the multiplicity expression indicates that the number of attributes per instance of the class, what are the number of attributes per instance of the class are available. That means the sensor status, it is looks like an array, and that means number of sensor status is 10. Okay, and an attribute without square bracket must hold exactly one value. If we do not omitted this square bracket, then it is a single value attributes, and single value variable like attributes, and it should hold only single value. But if it is looks like this, then it is a 10 value. This sensor status will hold 10 values. Looks like it is like an array. An attribute, the type of an attribute is written by as follows. The type, you may write the sensor status within bracket the number of instances, it is 1, and then within a colon, then you may give this int. Here int means it is the type of this attribute sensor status. That means in programming language we say this is a variable, and the type of this variable is int. The attribute name may be followed by an initialization expression. The initialization expression can consist of an equal sign and an initial value that is used to initialize the attributes to the newly created objects. So here we have initialized this sensor status by a 0. This 0 will initialize all the variables, all the positions of this variable, and it should be in int, and thus by equal sign we can initialize an attribute, and this type of initialization is also possible in a class attributes. Then the operation names are typically left justified in plain type and always begin with a lowercase. The operation always begin with a lowercase. Abstract operations are written in italics. Abstract operation. Remember that abstract operations are those for which the implementation is not provided during the class definition. Abstract operations are those operations whose implementation are not provided in the class definition. Okay, the parameters of a function may have the parameters of a kind. There are the different types of parameters. Obviously, the parameters is looks like first one is int parameter. It actually indicate the parameters in which is passed into the operation. If the parameter is passed into the operation, then we preceded it by in. If the parameter is only returned from that operation, then we preceded that parameter by out. And in out actually indicates the parameter is used for passing data into the operation and getting the result of the operation. That means it is a both case that it will pass the parameter to the operation, pass the value to the operation, and also it will return the value through the operation. And if you do not put anything, then the default is in. Here is an example issue book. Issue book in book name colon boolean. That means the operation may have class. This operation means that this book name with an input of this issue book operation, and the input type is boolean. Often a distinction is made between the terms operation and method. An operation is something that is supported by a class and invoked by objects of other class. There can be multiple methods implementing the same operation. We have pointed out earlier that what is the static. We have already discussed that what is static polymorphism. We know that in static polymorphism we cannot write multiple operations in the same name. But if it is a method, then we can make the polymorphism of those methods. Here are some sign of the operation which means something different. The plus, minus, and hash symbol. The plus symbol denotes the public attributes of our operations. That means if this operation is public, that means any other class member may access this operation, then we have given here the plus sign. If we give the minus sign, that means this is the private operation. Any other outside class cannot access this operation directly. And hash denotes the protected attributes of operations. That means it is a protected type members of class. Okay. Next, the association. Association between two classes is represented by drawing a static straight line between the concerned classes. The name of association is written alongside the association line, and an arrowhead may be placed on the association line to indicate the reading direction of the association. This arrowhead means from the reading direction of the association. This arrowhead means you have to association from here to there, here to there. That means book to library member. Okay. On each side of the association relation, the multiplicity is noted as an individual number or as a value range. The multiplicity indicates how many instances of class are associated with other. This multiplicity means that how many class members of this class is associated with how many members. Here star here 1 means that any number of book member may be associated with a single library member. Any number of or more than 0 or more than 0, number of books may be borrowed by a library member, a single library member. So this is called association. The value ranges of multiplicity are noted by specifying the minimum and maximum value, and it is separated by two dots. For example, 1 dot dot 5. If we write 1 dot dot 5, that means 1 is the minimum value and 5 is the maximum value. Okay, and asterisk is used for wildcard, and you know the meaning that the value is 0 or more. The here we should read this, that many books may be borrowed by a library member. Okay, associations are useful, usually realized by assigning appropriate reference attributes of the classes involved. Association can be implemented using pointers from one object class to another class. Next, the aggregation. Aggregation is a special type of association relation where it involves the classes are not only associated to each other, but a whole part of relationship exists between them. Here, aggregation means not the it should not a part of a class, that means a value of a class or only some attributes of a class are not associated with other classes. That means the whole class is associated with this class. Okay, the aggregated object is not only known the addresses of its part and therefore invoke the methods of its parts, but also takes the responsibility of the uh, creating and destroying of its parts. For example, a book register is an aggregation of book object. If we say that a book register is an aggregation of book objects, books can be added to register and deleted as when it is required. So book object is fully associated with this book register. Aggregation is represented here by an empty diamond symbol at the aggregate end of the relationship, and this diamond symbol should be at the end of this relationship. So this is the end and this is the start. This here the figure fact that a document can be considered as an aggregation of paragraphs. A document can be considered as an aggregation of paragraphs, and each paragraph can in turn be considered as aggregation of lines. That means all the lines combined and aggregated and makes a paragraph. All the paragraphs combined and aggregated into a document. That's why here this class are fully, the line class is fully associated with the paragraph class is fully associated with the document. There is no parts are lived into the paragraph which is not associated with the document. So this means that one document can have many paragraphs. On the other hand, if we wanted to indicate that a document consists of exactly 10 paragraphs, then we would have written number 10 in place of asterisk. Each paragraph the aggregation relationship can be reflexive or recursive. That is, an object can contain objects of the same class as itself. An object cannot contain objects of the same class. Also, the aggregation relation is not symmetric. That is, two classes, if there is two class A and B, they cannot contain instances to each other. So that's why the aggregation relationship cannot be reflexive. However, the aggregation relationship can be transitive. Here, in this case, the aggregation may consist of an arbitrary number of levels. Transitive, and obviously it may be any arbitrary number of levels also possible, but the aggregation relationship cannot be reflexive or recursive. Okay. Now, composition. Composition is some more stricter from the aggregation, in which the parts are existence dependent on the whole. The parts are existence dependent on the whole. That means that the life of the parts cannot exist outside the whole. The life of the parts cannot exist outside the whole. In other words, we may say that the lifeline of the whole and the parts are identical. The lifeline of the whole and the parts are identical. In the previous example, there may be possible there are some paragraphs which is not into this document. That means the whole paragraphs, no, sorry. So the whole paragraphs are associated with this document. Well, the whole items of these paragraphs are associated with this document. But here, if we say item and order, the item does not exist. Those items does not exist if there is no order. So in this typical example of composition is an order object where after placing the order, no item is ordered, cannot be changed. If we cannot change, then any order items are required after the order has been placed. Then the entire order has to be cancelled and a new order has to be placed with the change items. That means we are order some items and we cannot change the item. If this is our constraint, then only we will get those items only when we change or cancel that item, that order. So that is the whole existence dependent, that items are existence dependent in the order. If order is present, then item is present. If order is not present, then item is not present. Okay, so that is why it is called the existence dependent. In this case, as soon as the order object is created, all the order items in it is created, and as soon as the order object is destroyed, all order items are to be destroyed. That is, the life of the order items is the same as the aggregator orders. The life of the order items existed on the orders. If there are order, then there are item. If there are no order, then there is no item. The composition relationship is represented as a field diamond. Here is a field diamond. It should be end in the composite end, and we have found the example already. And aggregation versus composition, both aggregation and composition represent the whole relationship normally. Okay, when the components are dynamically be added and removed from the aggregate, then the relationship is aggregation. When the components can dynamically be added and removed from the aggregate, then the relationship is aggregation. But if the components cannot be dynamically added or deleted, then the components have the same lifetime as the composite. So in that case, the relationship is represented by composition. Okay. So in this case, we cannot add a single item into because it is a composition. So we have to add all the items at a time, and we have to make the order ID. Okay. When the components can dynamically be added and removed from an aggregate, then the relationship is aggregation. If the components cannot be dynamically added or deleted, then this relationship is called the composite relationship. In the order, in this order, a single order, there may be many order items. If order once placed, then items cannot be changed at all. If in this case the order is a composition of order items, and however, if order items can be changed, we can added, deleted or modified items, then it is an aggregation relationship. Then in that case, it is not an composition. It will be only composition if there is a constraint that you cannot add, delete or modify the items anytime dynamically with the single order. If you need to add more items, then you have to delete the order, and then you have to reorder all the items. So in that case, it is a composition. Okay. And Now, inheritance, this concept is very much clear to you. I am just saying that the inheritance relationship is represented by an empty arrow pointing to the subclass of the superclass. This arrow should be empty. Okay, the arrow may be directly drawn from the subclass to superclass. Array should be this arrow should be drawn from subclass to superclass. Do not write this arrow from superclass to subclass. Keep in mind that this arrow should be directly drawn, maybe directly or indirectly you can drawn from subclass to superclass. And when there are many subclasses or of a base class, then inheritance arrow may be combined to a single line like this, may be combined to a single line, and the labeled with the aspect of the class that is abstracted. The direct arrows allow flexibility in laying out the diagram and can easily be drawn by hand also. The combined arrow emphasizes the collectively of the subclasses when the specification has done of the basis of the sums of some discriminator. Okay, the set of subclasses of a class having the same discriminator is called a partition. It is often helpful to mention the discriminator during modeling, as this become documented design decisions. So these becomes documented design decisions. In that case, you know how to which classes are superclass and which classes are subclasses. Then the dependency. A dependency relationship is shown here a dotted line. Shown here a dotted line, and that means that this is the dependent class and arrow sign will be on the independent class. This is the dependent class, this is the independent class. If we draw a view in the concept of DBMS, if we draw a view of a customer of a customer class, then this customer view is fully dependent on customer. Without customer, this customer view is not existence dependent, not existed. That's why this is called dependency, and dependency is shown here in the dotted line. Okay, and then the constraint. A constraint describes a condition of an integrity rule. Constraints are typically used to describe the permissible set of values of an attribute. Permissible set of values of an attribute to specify the pre and post conditions of the operations. To define certain okay, constraint. A constraint describes a condition or an integrity rule, and constraints are typically used to describe the permissible set of values of an attribute to specify the pre and post conditions for operations, to define certain ordering of items. For example, to denote that the books in library are sorted on ISBN number, we can annotate the book class with a constraint. So here the constraint are here in this example, the constraint are senior member group and person. Between person, if the age of the person is greater than 60, then he is a senior member group. He is in the senior member group. So this is the constraint of this senior member group class, and the constraint are shown here by a curly braces, and within the curly braces we should write whatever the constraint it is, whatever the logic or whatever the constraint it is into the curly braces. So precondition and post condition of the operations are should be shown through these conditions constraints. Then the object diagram. Like class diagram, the object diagram shows the snapshot of the objects, only the objects in a system of a point in time, because the value of the objects are changes time by time when the program is running. So the value of the object is, as it is changing, the object diagram may change in some moment of time. Since it shows the instances of the classes, rather the classes, and it is often called an instance of a diagram. It is often called as an instance diagram. The objects are drawn using here the rectangle, rounded rectangle. The classes are drawn in the rectangle, but the objects are drawn in a rounded rectangle. An object diagram, here the name of the object, then what are the values of the object, and then what are the operations are associated with that objects, and these operations are looks like the same as in class diagram. An object diagram may undergo continuous changes as execution proceeds, and it is useful, very much useful, to explain the working of a system. In some state, whatever the value of the system it is, this object diagram can show it. Then the sequence diagram. A sequence diagram shows the interaction among objects as a two-dimensional chart. Here we are looking that it is a two-dimensional chart. The chart is read from top to bottom. The objects participating in this interaction are shown at the top of this chart. These are the objects, list of the objects. And inside the box, the name of the object is written with a colon separating it from the name of the class. So first the name of the class should be written, and then within a colon, then a colon, and then the object of the class should be written. Here all the objects name are shown here, the class name are not shown here. When you write, you may write in this way, or you write the object class name, then colon, then the object name. This signifies that the referring of an arbitrary instance of the class. Here the colon book represents an arbitrary instance of a book class. Okay, this is the object name if it is after colon. An object appearing at the top of the sequence diagram signifies that the object existed even before the time the use case execution was initiated. That means if before the use case was initiated, this object was existed. However, if some object is created during the execution of the use case and participating in the interaction, then the object should be shown at the appropriate place of the diagram where it is created. And the vertical dashed lines, these vertical dashed lines is called object's lifeline. Any point on this lifeline implies that this object exists at that point. This line means this object exists in that point. Absence of lifeline after some point indicates that object ceases to exist after that point in time, but particular point of time not. Okay. Normally, at the point, if an object is destroyed, the lifeline of the object is crossed at that point, and the lifeline for the object is not drawn beyond that point. If this means that here the object belongs, but if after this line, if this object does not necessary, then you give a cross, and after that the object should not, this lifeline should not be drawn. Thus an activation symbol, a rectangle called the activation symbol drawn on the lifetime. This is called activation symbol. That means the object active in this moment. But all that time the object's lifetime is belongs, but this object is active only in this moment. Thus, an activation symbol indicates that the object is active as long as the symbol exists in the lifeline. Each message is indicated as the arrow between the lifeline of two objects. This is called message. This object sends find member borrowing message to this library member. So this message is comes from this object to this object. Each message should be labeled with some message name, and some control information can also be included here. Okay, a condition A condition indicates, condition means within the bracket, within the third bracket. If we write some condition, that indicates that a message is sent only if the condition is true. If the condition is true, then the message will be sent. Here, if it is reserved, then this apology message will be sent from this object to this object. And an iteration marker shown that the message is sent many times to multiple receiver objects, as would happen when you are iterating over a collection of elements of an array. And you can also indicate the basics of the iteration for within the third bracket. Here the iteration is not shown here, that's why I will show, cannot show here. In the letter I can show you the iteration example. The sequence diagram for the book renewal use case of the library automation software is shown here. It is the sequence diagram of book renewal process. Here the library boundary object renews the books. When the books is renewed, it finds the member borrowing, library member which member is borrowing the book actually. Then it send the information to books, which book is selected. Then if it is not selected, then send this object returns an apology. If it is not, then in this confirms the that yes, this book has been selected. And before going to confirm or before saying to apology, this book it actually finds the book is available into the book, this book object or not. And after sending the confirmation, it updates the information into the books also. No, sorry, before sending the confirmation, it updates that this book will be renewed into the book object. So these are the way of a sequence diagram. And collaboration diagram. A collaboration diagram shows both structural and behavioral aspect explicitly. This is unlike a sequence diagram, which actually shows only the behavioral aspects. The structural aspects of a collaboration diagram consist of objects, and linking among them indicates association, indicating some association. Each object is also called collaborator. This is also called, each object is also called collaborator, and the behavioral aspect is described by the set of messages exchanged among the different collaboration. This collaboration diagram is the behavior of each and every object as shown here. The library boundary, it the first it renew some book, so send message to the library book renewal controller. Then it sends the information to the library book register. Then it sends information that the find member, that the library member is available or not, or it is perfect or not. Then it displays the borrowing information. Then it selects the book, which book he would like to renew, and then he sends the selected book to the register. Then it finds try to find out the books are available or not. If it is not, then sends the apology. If it is and then this apology should be sent to the library software also. And but if the book is available, then it sends the update to the book information. And then 9 10, and then it confirms that the yes, your book has been updated. And at last this confirmation also sent to the library member. So these are the actually collaboration diagram, how each and every object are collaborated to each other, and how they sends information, how this program, how this software is going to run. And the last one is activity diagram. The activity diagram focuses on representing various activities or chunks of processing and their sequence of the activation. Activation diagram, actually the sequence of the activation will be done here. And the activities generally may not correspond to the methods of the class, but an activity is a state with an internal action of one or more outgoing transitions which automatically follow the termination of the internal activity. That means the activity of some internal termination are being shown into this activity diagram. If an activity has more than one outgoing transitions, then exact situation under which each is executed must be identified through appropriate conditions. So in the activity diagram, they are similar like the procedural flowchart. Whatever the flowchart we are learned, the activity diagram is looks like that. Many difference is that activity diagram supports description of parallel activities and synchronization aspects of everything is involved into this activity diagram. If we see an example, so here is an activity diagram, and the parallel activities, here the parallel activities are represented on an activity diagram by using swim lines. This is called swim lines. This swim lines enables you to group activity based on who is performing them. So all these activities are performed into a parallelly. That's why it is called the swim lines. The swim lanes subdivide the activities based on the responsibility of some components. Sorry, these are called swim lanes. These are called swim lanes. And the swim lanes corresponding to the academic section and the activities that are carried out by the academic section and the specific situation in which these are carried out and shown. So this academic section and this account section are divided by these swim lines. Activity diagrams normally employed in some business model, and this carried out during the initial stages of the requirement analysis and specification, and very useful to understand the complex situation. Here the student admission process is done, and it shows that part played by the different components of the institute and the admission procedure, how they receive the fees, when they receive the fees, when the account section receive the fees, in that time the parallelly hostel office, and parallelly hospital and the department, these three things will running on. Hostel office will done first, allot the hostel, then receive fees, and then allot the rooms. And in parallel, the hospital creates an hospital record and conducts a medical examination. Parallelly, the departments register the courses for those students, and after finishing all these tasks, then they will issue an identity card to the student. So that's this is the activity when a student wants to record or gives the fees to a institute. So these are the activity diagram. So these diagrams, the last one is state chart diagram. It is normally used to model how the state of an object changes in its lifetime, and state chart diagram are good to describe how the behavior of objects changes across several use case execution, and they are based on finite state machine. And finite state machine consists of a finite number of states corresponding to those of the objects being modeled. But the major disadvantage of finite state machine was the state explosion problem, where the number of states becomes too many and the model becomes too complex when we use in the finite state machine. But in the state chart diagram, that problem has been overcome. So the basic elements of a state chart is initial state. It represents as a field circle. Final state represented by a field circle inside a large circle, and the states, these are represented by rectangle with rounded corner, and there are some transition. It is shown as an arrow between two states. Normally the name of the event which causes the transition is places alongside the arrow. You can also assign a guard to the transition. A guard is a Boolean logic condition. The transition can take place only if the guard evaluates to true. Here is an example. of the what we have done. This is the initial state, this is the initial state, and this is the ending state or final state. And the rectangular rounded rectangular are state, the name of the state, and the transition is shows by the arrow. Okay, so unprocessed order, if we checked rejected, then it goes to rejected order and the program is finished. If that order is accepted, then it goes to the accepted order. If the accepted order is is processed, then it may be into the pending order, then it may be available into the fulfilled order, and after finishing the fulfilled the order, the state chart says that we have to make the new supply also. So this was the different types of charts